Okay, how's everybody doing? So how to wire the scratch built turnout. But before I go into that, I want to preface with something that's very important. Do you have a bus wire on your layout? If you're just starting out, or maybe you're having electrical problems, or you want to rewire your layout, do you have a bus? Let me give you an example. When a developer is going to build a community, let's say a sub-district or whatever, they run a water main. You know, whatever the main is, it could be, I don't know, a foot in diameter, 6-inch, whatever. So they run a water main down the main drag, or it's laid out in such a way that it can be tapped into from the whole district. You know, it might weave through, like in this case, a bus under a layout sort of weaves back and forth. So wherever you want to tap in to that water main, like wherever you build your house, let's say, up on this hill, down in the ravine, whatever, you can just take your hookup, right, plumbing, and it's tapped into the water main. This main is always consistent pressure. It's more pressure than you'd ever have in your house. So when it's divided up and multiplied, you're going to get high pressure all the time to every single unit, or in this case track, that's hooked up to the power source. So the main source of power comes in to the bus, and the main is consistent all the way through your whole layout. And then you tap in from your track source, wherever it is, and you solder into your main bus, and you've always got good current no matter where it is on the layout. It doesn't matter how far it is. As long as your bus is basically all one section and stretches the full length of your layout, right? Okay? So that's the main purpose of having electrical integrity through your whole layout. Like, here's just an example quick. Let's just pretend that both these turnouts have droppers and they're wired, as I'm going to show following this introduction. And let's just say there's two insulators right here and two insulators here. This track's going to be dead if it's relying on power from the track, right, alone. So this section will be dead here. But if I solder one dropper on each side, positive, negative, drill 2 holes and bring it down under the layout and solder into the bus, now this section is live. And I do that with every section of track. Not always with the small one like this, because in this case I used connectors here, so this little section is actually isolated right here, but it's part of this turnout, so it doesn't really matter. But it's still isolated. Like this actual turnout section right here is all isolated up to about here. So if I have an issue, I can isolate each section and find out what it is. But I haven't had any problems previously when I did it this way, but I like to build that in. So if you have a bus, you're always gonna, you're not gonna have voltage drops or funny, gremlins and anomalies that are gonna frustrate you and kill the hobby for you. Wire your layout properly. Use a bus. And this is a bit heavy for what you don't really need this. This is 12 gauge, I believe, but I had some around. But the bigger the better, in my opinion, less resistance. But you only need probably 14 or 16 gauge. Okay? And then run feeders. In this case, I'll use 6 from each turnout. Okay? So if you want no fuss, install a bus. Get good water pressure. Get good voltage. Okay, so I want to talk about wiring a turnout, because somebody had mentioned it a few episodes back, and I never really went over that because I sort of take it for granted, and it's probably not fair to do that because there's so many different people at different levels, and if you're going to get into scratch building a turnout, it seems intimidating at first, but if you get into it, it's the best way to go. It's easier to wire your turnouts because you can see them, you built them, you know what's going on. So basically with polarity, right? Like when I build my layout in the case of River Road, all the rail, the first thing I determine, the rail that faces me, that I'm closest to, is going to be positive. Okay, positive, positive. Just see a turnout as 2 sections of track like this, right? That's essentially what it is when you basically wire them, okay? So positive, 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 negative, right? And in this case, this one's negative. But this actual, what happens here is you have to isolate the frog, and you got to isolate down the middle of the track. But that's indicated on these beautiful drawings, like once again by, let me plug them again, like fasttracks.com or handlaidtrack.com. They're it. They have no peers when it comes to scratch building turnouts. So if you want to learn how to scratch build turnouts, go to their site, and they have everything you need there to make it easy. There's full support. There's YouTube videos. They're just fantastic. And I know they seem intimidating at first, but they're not that difficult. And they got beautiful jigs you can buy with the rail. They show you, they cut the section of rail, it drops into the aluminum jig plate, and I don't know what else to say, right? They're it anyway when it comes to turnouts for model railroading. So what I do is I just positive, right? Like when I wire this turnout, I wire droppers and I solder on the bottom, right? Here, 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 and here, and here. And then I also put one on the frog. I'll talk about that in a second. So the only cuts that are made is where the frog is, right here, as indicated in the drawing. And then the isolation gaps, which I use a file, right? And they're indicated here. If you go according to the drawing, do it exactly the way they show you, you won't have any shorts, okay? Now you can isolate the copper cut through to the fiberglass later with a Dremel tool if you want. I used to do that, but the problem with that is sometimes, depending on your touch, you'll cut into the fiberglass a bit too much, depending on the thickness of the PC board. They come in different thicknesses, right? Whatever. I don't know which one Fast Track is. I cut my own strips from sheet, but I like to do them with a little file, right? Like this. First, like before I glue them down to the paper template, I like to cut through with a file first, and then just glue them in place. And then they're all done, right? Okay? So I just wire droppers on each end of the turnout. So I want to wire the whole turnout separate from the rest of the layout, okay? And I'm not going to depend on my approach track to light this turnout up current. It's going to be droppers down to the bus, right? Okay, so positive, 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 right? Like this is always the rail that's facing you. Okay, then negative, negative. So negative, positive, negative, positive, negative, positive. Simple, right? Forget about the frog right now. Okay? Now, underneath my layout, and if you don't have this, you're doing it wrong. So you have a bus. In this case, I have 12 gauge. 14 is all you need. Solid copper wire. You can get it at Home Depot, wherever. You run this under your layout. You drill holes in your framing. You run it all through first. You put your bus in. So when you connect your power supply, regardless of whether it's DC wave or DCC notch or whatever, step, right? It doesn't matter. These turnouts will run at a flick of a switch or just by unhooking your DCC and then hook up a DC. If you wire these this way, they'll work either way. The only difference is your power source, okay? All right? So you take your droppers, you drill through your layout, and they drop down. In this case, I use black for negative, red for positive. Okay, so simple, right? So when my wires come down through the layout, I know that red goes to red. I know that black goes to black, okay? So the turnout is wired, so when I power into my bus, the current goes down and goes up. All the feeders, all the droppers wire, right? And voila, your system is fully functional. Even if I isolate the turnout with insulators, which I like to do, that's for another discussion, it doesn't matter because I have droppers from every section of track going down to my bus, which is never isolated. Unless you use blocks. Right, that's another discussion too. Like you can use your bus as separate blocks on a larger layout, which is a whole nother discussion. It's okay. But in this case, this is just a 20-foot shelf layout or whatever. It doesn't matter. I'm just going to have it as one block. Okay. Or I can break it down to two. But anyway, that doesn't matter right now. So basically, you just simply wire each end of the turnout. So you use 6 dropper wires, right? Okay. If the turnout's this way, it's positive, positive, negative, negative. If I turn it this way, it's just reversed. Okay. So if you do it, if you build it according to the plan, you shouldn't have any problems. Now with the frog, you can leave it dead. You don't have to power the frog in most cases now with most contemporary or current locomotives, as far back as I think 20 years or more, have both powered trucks. So by the time the truck, even when the first truck runs over the dead frog, it picks up power on this side, because this rail is always going to be hot because it's soldered to this rail through here, right? So it's just a small dead spot, but the trailing truck will pick up power to the motor anyway. And then once the trailing truck comes over the dead frog, the leading truck is already picking up current. So you won't even notice. So why should I bother then? Why bother to power route the frog? Well, because for better reliability, okay, and other reasons too, right? There's other options for signaling and stuff like that. But that's another chapter. But I like to power out my frogs because I want continuous, reliable continuity with whatever route that I take on the layout. So this will change positive, negative, depending. If it's coming through here, the frog changes to negative. If it's coming through here, it changes to positive through the little DPD switch that will be on your switch machine, okay? Some will have it like this with 3 tabs coming off it. So you got positive going into one like this, and then negative from your bus. And then this yellow wire goes to my frog. And so when the switch gets pressed, however way that works, it switches negative, positive, back and forth depending on the diverging route. So you'll always have this effect. If you're going straight through, it'll be positive, negative. Or if you're going to take the diverging route, it'll be positive, negative. Like all the way through, there won't be any dead rail. Okay? That's the power routed frog. So you can leave it dead if you want, if you don't have any problems. But if you want, you know, really good reliability, then power route your frogs. So when you're idling and running through and sitting on a turnout, you'll never have to worry. Like maybe one truck has a dirty wheel or something, and it's not picking up the one that's on the live rail, and your other truck's sitting on the frog, which is dead, right? So your locomotive's going to shut down, or in this case, DCC sound goes off, everything. But then again, if you have, you know, the very latest DCC keep alives, it won't matter at all. So this is debatable if you're all keep alive DCC. But I like to power route them anyway, okay? So pretty simple, right? Positive, negative, red, black, positive, negative on your bus. Drill down through. All your wires will be hanging down like spaghetti. You'll know where they go, okay?